I'd like to welcome you to this Kubernetes by Example course. In this course, we are going to be showing you how to take a Spring Boot application and run it in Kubernetes. So there's a number of things that we need to do when we're running Spring applications. Obviously, we want to be exposing ports, running it in Docker, getting it containerized, bringing it up in Kubernetes, deploying it in Kubernetes. So there's a lot that we need to do, like environment variables and stuff like that. We will be covering that in this course. A very simple example. The purpose of this course is to have you find success taking a simple Spring Boot application and bringing it up locally in your Kubernetes environment. We'll be able to go to that application and get information from the REST API. The first thing we need to do is get your environment set up. The next couple lessons we're going to be talking about what you need to have running locally on your system, which is obviously Kubernetes. A couple different ways that we can do that, but we'll cover that in this section of the course. And then we'll get started taking a look at the Spring Boot application and how we can deploy that using Kubernetes. In this video, we're going to talk about setting up your development environment. So for Java development, we're going to need any operating system, which is probably an operating system that you are using, Mac OS, Windows, Linux. I'm saying 8 gig of memory is probably the minimum. 16 gig or more is probably preferred just because of the nature of running Java and our IDEs and whatnot. They do tend to take up a good bit of memory. We will be using Java 11 or higher. You can use the official Oracle Java or OpenJDK. That is up to you, but be sure to have JDK installed. Docker Engine 2.0.10 or 0 or higher is what I'm recommending for the course. And then as far as build tools, if we get into those, we'll be using Maven version 3.6.0 or higher. Ideally, you want that installed for command line use. If you have any questions about that, see the official Apache Maven documentation. They do a pretty good job of explaining that, and it does vary depending on what operating system you are using. So verify your environment. Make sure that Java is installed. You can do that with Java minus version. Make sure the JDK is installed. I see that happen sometimes where you install the incorrect flavor of Java and get a JRE rather than a JDK. And to verify that, you can use Java C version. That tells you that the Java compiler is there, therefore you have the JDK. Maven, from the command line, ideally you'll be able to run mvn-v to show the version. And then Docker, of course, we want to see Docker PS. In the source code examples, I will be using IntelliJ Ultimate. This is a paid product, but it is not required. I'm using anything that we build is going to be used through Maven. That is a build tool, which is supported by free IDE options such as STS, Eclipse, and NetBeans. So those all support Maven. Maven can also be solely used from the command line. So you could use just a text editor and the command line and you would be just fine. So IntelliJ definitely is not required for the course. Kubernetes, as we get into the Kubernetes content, you are going to need access to a Kubernetes cluster. Now, online, you can use the OpenShift Playground. Just Google OpenShift Playground. It'll take you right to it. You can get a free hour within a Kubernetes cluster to do what you would like. I will be running locally. So if you've installed Docker Desktop, I am running Mac OS, and I have installed that. You can simply enable that. So via Docker Desktop, this is probably going to be the easiest option if you have Docker Desktop installed. And then Minikube is a VM based that is available for most major operating systems. Or Kind, this is another project that is Docker based. And depending on how you set things up, you do want to have kube control configured to connect to your cluster options. So depending on how you've decided to run your cluster, that is going to be one option that you can utilize. Okay, in this video, we are going to go through as far as setting up Kubernetes using Docker Desktop. So to do so, this is only if you're running Docker Desktop. Come into Preferences for Docker Desktop, and you can see here I am using the Mac OS version. There's a tab for Kubernetes. If you're using Windows, it can be fairly similar to this. All we have to do is come over here and enable Kubernetes. And you can see here, show system containers. We don't need to see those, so this is automatically going to hide these. So Docker Desktop does work similar. It does bring up a single node Kubernetes, air quotes, cluster. Single node cluster seems like a contradiction in terms to me, but it will bring up a single node cluster. All we have to do is say apply and restart. And we can see that it takes a few minutes. That's because it's probably going to bring down some containers for this to support the cluster. And this will get Kubernetes on our system. And again, if you're running Docker Desktop, this is probably the easiest path to go as far as getting a local Kubernetes system running on your system. If you are not, I listed out a couple options previously, but to continue with the course, we will need Kubernetes up and running on your system. Okay, it took a few minutes for everything to get started. You can see here that I've enabled it. You'll see a progress bar while it starts up. And I did not take the option to show system containers. So you can't see them, and they're not going to be listed under everything. So if I come back over here to the command line, even if I do docker ps, you can see that I have Postgres and admin. These are two containers that I have up running, but we don't see anything for Kubernetes. But we do know from the UI that we expect that it is up and running. So let's come over to the command line. And if I do kube control, that's a git nodes. You can see that it's prompting me for a username. It should not be doing that. So I'm going to control C out of that. And if I had some other version, such as Minikube installed at one time, I might have to go ahead and set it to use the desktop version. And so what we can do is kube control config get context. You can see that I do have another one there. So at some point in time, it looks like the second one was created there. We want the Docker Desktop. So what I want to do is tell it to use that. And depending on how you set things up, you might not have to do this step. But I've done quite a bit of development on this machine over the years. I want to say kube control config use context, like so. So we switch the context in the kube control. Let me clear this. Now we should be able to use kube control get nodes. And you can see that we did connect to the Docker Desktop Kubernetes cluster, and says that we are ready. And we're not really running much right now, so not much to see, but we are able to connect to the Docker Desktop Kubernetes single node cluster. Okay, now that we got the basic housekeeping done, got your Kubernetes environment set up, we will be taking a look at deploying the Spring Boot application using Kubernetes. So we have a series of lessons here in this section of the course to take a Spring Boot application, we'll deploy it into Kubernetes, as well as define a service so that we can access that Spring Boot application running inside of Kubernetes. So a lot of fun content in this section, all about taking a Spring Boot application that is already done, ready to go in a container, but we are going to use Kubernetes and the Kubernetes environment with Spring Boot. Okay, in this video, what we want to do is deploy our REST brewery. So previously in a course, I showed you how to take this Spring Boot application and build a Docker image of that. So now what we want to do is we want to take this, this is published up to Docker Hub, so you'll be able to access this pretty easily if you don't want to go through the time to generate your own image. So you can go ahead and utilize this and follow directly along with what I'm doing in the course here. So this is a simple REST application. I will leave in the course resources up here, SFG Beerworks Brewery API. So we have a basic CRUD application. That's the Spring Boot application that we are going to deploy to Kubernetes. So this is a nice little application for us to work with. So I'm going to toggle over to the command line now, and we'll take a closer look at this. So I'm in the command line, and what we can do is we can do kubectl get all, and we can see we've got our cluster is up. Nothing is running right now, so that's exactly where we want to be. I'm going to go ahead and clear this. And what we can do is we can also use kube control to actually create the deployment YAML. So there's quite a bit to it. And we are going to accept some defaults and have the tool generate the YAML file for us. So I'm going to say kube control. We want to do create a deployment. We are going to call this KBE REST. That is the name of the application we are deploying. And then image is going to be Spring Framework Guru / so that's the name of my GitHub repository. And this is going to be KBE REST brewery, like so. So that's the name of the image up inside of Docker Hub. Now we're going to say, do a command called dry run. And it used to just be this. There's a recent change where you have to say client. And what this does is it tells it to run locally. We're only going to run the command. We're not actually doing the deployment because we want to generate the actual YAML for it. And we're going to do a redirect to a file, and let's call this deployment YAML, like so. And we hit enter, runs pretty quick. And we can see that I do have a deployment YAML file that has been generated. So if I come in and view that, I'm using Vim. Now we can see this is a YAML that was generated by kube control quite a bit here, but we're saying that we want one replica. So we'll have one of these running. And then down here, the containers, we can see that that is the image that we specified. So we did not specify a tag, so by default, it's going to grab this latest tag from the repository. So pretty simple. At this time, we're not going to dive too deep into the actual options inside the YAML. This is kind of the default that has been generated, but this is the YAML specification that tells Kubernetes how to or what to deploy. So I don't need to write. I'm just going to do a quit. I clear this. Now, to actually get this to run, we need to do kubectl apply. So this is a generic command to apply. And I'm saying -f. And I want to take that YAML file that we just generated. So we'll go ahead and deploy that. And we can see here that I get that was created. So now if I let's clear and do, and we can see that a pod has been created. So right at the top there, we see pod KBE REST. It's got a number and that the status is running. So nothing else has really changed. We have a deployment of KBE REST. We say 101 is ready, up to date, 1 available, desired, current. So we only told it to create one. So we're only using one instance in our little single node cluster. So nothing too exciting going on here except for that we do have this running. And if I do docker ps, we can see here from Docker that that container is actually running now. So that is up and running. Currently not exposed to anything, but it is up and running in a Kubernetes context. Okay, once the deployment is completed, we can actually configure it as a service. So let's go ahead and do that. Very similar process, very similar commands. So again, we're going to use kube control to create the YAML file for us. So we'll say kube control. Here we're going to say create service cluster IP. And we're going to give it the name that we did before. So that was KBE REST. In this case, we want to expose the ports. So we want to do TCP equals. Remember, Tomcat's running on 8080. We're going to expose that port for that. And again, we're going to use this drive run flag because we're not telling kube control to actually create the service. We want that to actually be output. And then we need to do the -o of YAML for the output. And again, we're going to redirect that, and we will call this service YAML. Like so. See, that runs pretty quick. I do an ls. You can see that I have the deployment that we previously created. Now we have the service. And now if I come in and do kube control, again, apply, -f for file, This time we're going to tell it the service, and we can see that that gets created fairly quick. And we can do cube control again, get all, and now we can see the service has been created. Right here, we have the service KBE REST, gets a cluster IP, so this is giving a specific IP address, and also exposing the port 8080 where our Tomcat application server is running. So that was the command to create the service. We never did take a look at the actual file, so let's go ahead and do that. I'm going to go ahead and do a VI into the service, and you can see again this is YAML, so API version 1, kind service. It provides it some metadata, but the primary thing that we are looking at is the ports 8080 protocol TCP, and then the selector, it's going to the app that we previously created in the deployment of KBE REST, and we're giving it a type of cluster IP. So again, this is a very minimal service file of the creation, and we just specified the basic options that we needed to create this. And if you're not familiar with VI, just :Q to exit that, and we'll go ahead and clear this. Okay, we are going to talk about trying to access our services. So one of the problems that we have, if we do, let's take a look at this cube control, get all. So we can see that our services are up and running. So we have a pod for our KBE REST. You can see that on the third line down there. That is up and running. Our REST service is running. The server says that it is on port 8080. The problem that we are running into here as far as accessing that, this is, I'm going to take a really, really complex topic and try to explain it in a very simplistic way. What's happening is our Kubernetes cluster is creating its own network. It's like its own virtual network. Granted, it's running on our machine, but one of the tells that you can tell if you're a layperson at networking is we are using 10 addresses. So that's an internal IP address that is internal to the Kubernetes cluster. So if I come in here and do, depending on your OS, this command is going to change a little bit, especially for Windows. So here I'm using ipconfig get IF address EN0. So that is for my wireless network card. So the wireless network, I can see that I'm on a 192 network. So the 192 stanza is different from 10. In other words, my network is not set up to talk to that network. We don't have a bridge set up. There's no way for network traffic to get from point A to point B. So even though everything is up, happy in a Kubernetes context, if we had other services running inside of Kubernetes that could talk to each other happily. The problem is for me on the command line here, I'm outside the cluster. I cannot go in. You might go, well, how about if I just go to this IP address? That's not going to work. Let me toggle over to Postman. Even though it's running on 8080, that's going to be the 127.00.1 address. We can see that this is not going to set up. There is a utility that we can utilize. I'm going to show you two different ways of getting from network A to network B. We can come back over to the command line. Let me do a clear here. And what I can do is say kube control service KBE REST, and then I can map 8080 to 8080 like so. And now we can see that I have this command doesn't come back. So it's going to forward that port traffic. So it's essentially setting up a tunnel to go from my network to the cluster network. Now, if I come over here, I have this. So I can do a curl. So we do have Spring Boot Actuator installed. And we can see that we are getting a up status back. And let me come back to Postman. If I run Postman now, you can see that I am in fact getting content back from our Spring Boot service. So that is now working properly. The route is established, but I come back over to the command line. It is established because I have port forwarding. We can see that we got some chatter there. Now, if I come in and do Command C, that terminates the tunnel. If I come back over here, run that, we see that we failed connect. And again, if I run in Postman, that is also going to fail. If I were to bring that back up, that would re-enable it. So that is one way for testing routes to the Kubernetes cluster, is to use this port forward service, or command, I should say. This is going to be more applicable when you are working locally with a Kubernetes cluster. So there's other techniques as far as exposing services to the world, but we're talking about on actual Kubernetes deployments, not a single node cluster that we are using to learn on. Okay, one thing that you'll see a lot of tutorials do is that they'll show you how to start things up, but they don't show you how to terminate things. So let's take a look at that in this video. And we're just going to use kube control get all. So we can see that we have a pod deploy, we have service, KBE service rest deployed, and we also have the deployment. So what we can do to terminate things that we've brought up so far, so we can use kube control, delete, service, and we'll just do the KBE rest. You can see it takes just a moment to run, and then you can see the KBE rest service was deleted. We can see that the service no longer is there. We can see the service for Kubernetes is still up with the cluster IP, but the KBE rest is now gone. And likewise, we can also do kube control delete deployment KBE rest, and that will terminate the deployment as well. So now we can take a look at that, come back and get all. We can see that now we don't have anything running in our Kubernetes cluster. And if I look at Docker, you can see that I don't have any Docker containers running it also. So now we've shut everything down, and pretty straightforward commands. So you can see kube control, delete, and then either service or deployment, and then the identifier that we gave them. In this case, it's KBE rest. So this is a handy way. Once we start things up, obviously at some point in time on our development systems, we're going to need to shut them down. So this is a very handy way to bring things up, shut them down. If we want, we can make changes and then restart them. So these are the commands that we use to shut down things that we've created in the Kubernetes cluster. Okay, previously we talked about setting up port forwarding to access services from our local host. And that's one method. I want to show you a second method inside this video here that could be a little bit more convenient in dealing with a Kubernetes running on a single node instance of Kubernetes running on localhost. There's a couple nuances that we are dealing with. Here, I'm going to show you a second technique that doesn't require us to use a tunnel. And this is something that we can bring up but make a little bit more permanent. And I am showing you one technique of several. We are going to be using what's called a NodePort. So what we want to do is come in and edit our services YAML definition. You can see down here on the type, cluster IP, we want to get rid of that and do node port, just like so. So this is a different type of definition for the service. We are saying node port, and this is going to expose a port on the local host that we'll be able to get to from the local host network into the Kubernetes cluster. And again, this is one way. There's a couple different techniques that we could actually approach. There's several actually. This is just another way that I want to show you how to do this. So in this case, we are going to hit escape and WQ to save this. And what I want to do now is and remember we shut everything down, so I'm going to say apply. I'm going to reapply the deployment. That is going to start the KBE rest container. We should be able to see that starting with Docker PS. And we can see that that container is up and running. Let me clear this. And now let's go ahead and do kube control, apply minus F in the service. And we can see that was created. I clear the screen here, and we'll do kubectl get all. And here, the important part about using NodePort, so we can see here that we have the service, KBE REST, NodePort. This is important because now we have a NodePort. We don't have an external IP, but it's going to get mapped to localhost, and we see ports 8080 and then this 31569. So this is a TCP port, and I'm going to copy that. And let's toggle over to Postman. You can see I'm in Postman now. I'm going to localhost, and that port gets generated at random when we create the node port mapping. And here you can see that I'm doing localhost port, and this is for the REST API that's running in our container. You can see that now I'm getting data back from that. So that is data coming back from the Spring Boot application. So let's just recap this real quick. Toggle back over to the terminal. Clear that. And what I changed here was this type of node port. So just edited the service spec, changed it over to node port, and quit out of that. And when we do kube control get all, when I see the service, this is the service that we created with a type of node port. This here port is what's getting mapped. So that will get mapped and be available on localhost, on the localhost network for us to access into our Kubernetes local cluster. Okay, for accessing a container's logs, it's pretty straightforward. So if I come in and do docker ps, we can see the containers that I have running. So that is the KBE REST brewery, the Spring Boot application that is running for Kubernetes. So if I grab this ID, and if I just do docker logs, like so, you can see that I'm getting the logs for that. And I could, if I was interested in tailing that, I could do -f, and then it would sit there, and if any new log data came up, I'd get that. However, in a Kubernetes context, I'll clear this. You might be working with a Kubernetes cluster, and you might not be on that node where Docker is running. So remember, when we deploy Kubernetes in a production environment, we're going to be dealing with multiple servers that are going to be running Docker and containers and whatnot. So you won't have that, be able to just jump into a node like that. Fortunately, for Kubernetes, we can easily see the same log data. So I can do kube control get all, and the set command shows me the pod that I'm interested in. So what I can do here is I'm just copying this pod identifier, and this would work with any pod in the cluster for Kubernetes. So what I can do is, again, kube control, I can say logs, I can say tail equals 20, and then pass in the name of the pod, and that will provide the log information inside the log. And then also I could do -f to follow if I want to follow logs. So you can see here that I'm in the screen, and if there's any new log information, that would be initialized here. Unfortunately, we don't have anything outputting log data. The container is just up and running and waiting for requests. But if I did have activity that I wanted to monitor, I would be able to do it through this utility. So let me clear that. So again, those commands are kube control logs -f to follow, or you can do a -tail equals 20, or however many last few lines that you want from that. And that is also optional, so you don't need to give that. You can omit that, hit that, and then it's just going to show you the log data. And I'm honestly not sure what the default there is. So it is going to show you a screen full of log data without that. So pretty handy utility to see the logs of your application running inside the container. In this video, we're going to talk about setting environment variables. And one very common use case is to use environment variables to override log levels. So let me toggle over to IntelliJ real quick. So you can see here for this application, the application properties that's getting deployed. So I have everything in a package called Guru Spring Framework SFG REST Brewery, and that is at a debug level right now. So I come back over to the command line, and we can do kubectl get all, and let's do kubectl logs, and we'll pass it in the ID of this container. And here we can see in my beer loader, we are getting loading initial data. So count is 0. You see that we have the start of that, but the primary one is here we have count is 0, and this is from Guru, Spring Framework, Raspberry, Bootstrap, and we can see this is log output. And we are at a debug level, so we can see that right in the log data. And for a deployment, a lot of times, development-wise, we love getting log data at a debug level. But when we have stuff running in production, obviously that's not something that we want. So what we can do is clear this, and here, let's come in and edit the deployment, like so, and come down here. And in the containers, we can actually set another property, and that is going to be here. I'm going to come in. Actually, I want to use spaces here for YAML. I'm going to say env, and this is going to take a name value pair as a list of different environment properties that we are going to be setting. And here, what I want to do is say name, and what we want to do is for the properties that we set in our property file, it's going to be all uppercase with an underscore. So we'll do logging so that is going to be the environment property name, and then we give it another property for the value, creatively named value. And in this case, we're going to switch it to the info log level. So this sets up the environment property. And again, just remember in our property files, we're going to have name dot name. Here we're going to go name underscore name. So logging underscore level underscore guru package name, and then the value of info. So let's go ahead and write that. And here, another thing we can do, what we can do here is we do have that up and running. We can see that's going for 6 minutes. We can do apply -f, and this is going to tell Kubernetes to go ahead and reapply that. It changes, and it will cause that container to restart with a new environment variable. And we see the get all. And here you can see one pod is terminating and another one is starting. So let's grab this one. And it actually started up before I could get that command in. But you can see now the debug log information is no longer there. So that environment property has been applied to the container, and we've changed the log level of our Spring Boot application. So now we are not dumping that debug information into our container log. So again, this is a very common use case. So when we have stuff that we're debugging locally as a developer, obviously we like that. When we are running in a deployment environment, typically we don't want to have all that debug log data going through our system. So let me clear this and just take a quick look at that. You can see down here on the bottom, for our spec on the containers, we edited this file and we put in the property env, which is going to take a list of environment variables. And that is going to be setting up the log level for my package to info, overriding what is in our Spring Boot deployment artifact. Okay, in this video, we are going to talk about setting a readiness probe. So readiness probe basically tells Kubernetes that the container is ready to start accepting traffic. And if you're running Spring Boot 2.3 or higher, this will be available in the Spring Boot Actuator. So very important that you're on a more modern version of Spring Boot to have this functionality. Otherwise, what I'm showing you in this video will not work. So again, it's Spring Boot 2.3 or higher. And we need to do two things here to enable the readiness probe. One is to set the environment properties for Spring Boot Actuator to enable this. And then the second is to tell Kubernetes to utilize it. And we'll do both of those in the deployment YAML, the descriptor for our Spring Boot application. So here you can see for the environment property, we'll go ahead and work on this. So again, this is going to be a name value pair, and in YAML this is going to be a list. So we'll do name, and in this case it is management underscore endpoint underscore health. Again, this is for the Spring Boot Actuator. So management endpoint health probes enabled. Just double checking, make sure I don't have a typo there. And in this case, we want to give it a value of true. And we also need to go ahead and add in a second property. And this is going to be management. And we'll do readiness. And again, the value would be true. And then also we need to set up a new property for this. And this is for the Kubernetes configure. So these two environment properties that we set are going to basically tell Spring Boot to expose the probe. And now we need to configure the probe for Kubernetes to use it. So the way we do this is set up readiness probe. So that's going to be an HTTP GET. Port 8080, that's the port that Tomcat's coming up on, the default port. And then path. Health readiness. So that's configures Kubernetes, telling Kubernetes to go do an HTTP GET against port 8080 at that path of actuator health readiness. So let's go ahead and write this file, and then kube control, apply -f, deployment, deployment YAML, and made a mistake there. Let me pause this and resolve this. So I took a closer look at the problem there, and Kubernetes is expecting these values to be explicitly strings, and it did not like the unescaped Boolean values, but going ahead and setting those values to strings using the quotes. I think with YAML you can also use single quotes. That did clear up the problem. So I reloaded it. It did load up properly, and let's go ahead and quit out of the YAML. And you can see the kube control get all. Let me clear this and get a better view for you. You can see that we are up and running properly, so the readiness probe is working. And let me toggle over to Postman. You can see here I'm going to actuator health readiness. I can go ahead and send that, and we can see that endpoint is being exposed, and we are getting a status back of up. So that is the desired response for Spring Boot Actuator. So let me toggle back over to the terminal. And just to recap what we changed here, we added in the environment properties for management and endpoint health probes enabled, and then specifically management health readiness state enabled. And then we do have, for the Boolean properties, we do have to escape those as proper strings. And then to tell Kubernetes to use the readiness probe, we are doing readiness probe, specifying an HTTP GET on port 8080, and that goes to the Spring Boot Actuator health readiness URL. And you can see from the Postman example that path is exposed and returning back an up status for us. In this video, we are going to create the liveness probe. So that's slightly different than a readiness probe. The readiness probe basically tells Kubernetes when the application has started up and is ready to start accepting traffic. A liveness probe is a health check saying that, hey, I'm alive and I can continue to accept traffic. So slight difference, but very important nonetheless. So I'm going to go in and edit the deployment. And want to come down here, we do have to set one more environment property. I'm going to come in here and say, and again, this is to enable, go ahead and enable that liveness probe. So we're going to come in and say name, again, it's management health. And this time it is liveness state. And we'll give this a value. And just as before, we can come in here. And let me try to get this up off the bottom a little bit. This time we have a liveness. Again, we'll be using an HTTP GET. Yeah, it's actuator health. And creatively, this is going to be liveness. So this is going to be our health check. So I'm just going to double check the spelling there. That all looks correct. So let's go ahead and save this. And again, we can go ahead and apply this. I'm going to go ahead and fix this real quick. I'm going to pause the video while I do so. So came in, so I have a typo there. I have a quote instead of a colon. So very, very easy mistake to make. So I suspect this will work much better now. And we can see that that has been applied. And we can see that we have one instance terminating, the other one starting. And we'll go ahead and get this one that's starting up. Take a quick look at the logs. And we can see that we are up and running. And now we are up on 3159. That is the port that this came back up on. Let's toggle over to Postman. Go ahead and send that. You can see that we are up on the readiness. Let's check the liveness endpoint. And we can see that is up as well. Come back over to the command line. And we can see that our application is up and running. Again, Kubernetes has now been configured to periodically check that endpoint to make sure that the service is up. So we configured two things. One is a readiness, that is basically saying to Kubernetes that the service is started up and is ready to start accepting requests. The other one is a health check, the liveness, that tells us that the application is still alive and able to accept traffic. So if we look at our deployment, you can see here, this is the complete configuration for it. So we've had to set up 3 different environment variables. So starting up with to enable the health probes, to enable the readiness, and then also to enable the liveness state. And then we have the liveness probe. That is, they are both doing HTTP GETs against port 8080. And for the liveness, we are going actuator health liveness. And creatively enough, for the readiness, we are actuator health readiness, the 2 different paths that Kubernetes are going to be using to monitor our Spring Boot application. Okay, another feature that is available in Spring Boot 2.3 or higher is the ability to handle a graceful shutdown. So what we don't want Kubernetes to do is terminate our application while it's still processing stuff. So we want to give that a little bit of time to complete properly. So again, very similar to the liveness and the readiness probes, we need to set a environment variable to enable this, and then also configure Kubernetes to utilize that. So let's go in, and we are going to edit the deployment descriptor again. And we'll go all the way down to the bottom here. And now what we want to do is come in here and say name. And this time it is going to be server and value. You're going to say Graceful. So this is a Spring Boot property saying that we are going to go ahead and try to shut down gracefully, allow any in-flight transactions to complete. So this is telling Spring Boot to go ahead and do this. Now what we need to do is tell Kubernetes to shut this down gracefully. So we can come in here and we want to say the lifecycle property. And we want to say pre-stop. And we want to give it a command to execute. I'm going to give it a command like so. And this is going to be a shell command. Very simple command. We're just going to say sleep for 10 seconds. Be sure to terminate that and then close that out. Let's double check this. That looks proper. And we'll go ahead and write this. And again, we can come in and say apply our deployment descriptor. And we can say that has been updated. You can see again, we have two services running, so we did that pretty quick. The second one is terminating. See if we can catch the logs on this one as it's starting up. It does start up pretty quick. We have a fairly light Spring Boot application there. And that is already up and running. And unfortunately, I don't have a good way to demonstrate that it's actually going to work. We could write some logging into a Spring Boot, into the Spring Bean lifecycle to show termination events, but I don't have a handy way to prove that we are getting a graceful shutdown. But just to recap for the configuration of this, what we wanted to do here, we added in this server shutdown of Graceful, so that it's going to tell Spring Boot to gracefully shut down. And it does give a life cycle. I think the default is 30 seconds for the life cycle, so that's a little bit of a mismatch there. You can override that. Refer to the Spring Boot documentation on that. This is a new feature of Spring Boot 2.3. But the primary thing is we are telling Spring Boot to do a graceful shutdown, and then on these three lines here, we are telling Kubernetes to give the application effectively 10 seconds to complete its shutdown activities.